All right, and last but not least, we're going to be looking at limits at infinity for transcendental functions, which means things like sines and cosines and ln's and all that kind of stuff. And really, there's no one way to analyze these. You have to just kind of be aware of what each of the different functions is doing. So one of the best ways to do these is to think about their graphs. We've said this from the beginning of this class, but you really do need to know what basic e to the x, ln x graphs look like. So we talked about this in one of the earlier videos for this lesson. Both sine and cosine do not have limits as x approaches either positive or negative infinity because they both oscillate, right? They just go up and down and up and down between 1 and -1 forever. So there's no actual limit that they approach. What about ln x? Let's think about its graph. Crosses here at 1. It has a vertical asymptote at x equals 0. But does it have a horizontal asymptote? It doesn't. It just keeps growing and growing slowly, but it constantly gets bigger. So again, even though it takes a lot, I shouldn't say a while, it's a slow growth, but it's constantly growing. So as x gets bigger, ln x is getting bigger as well. What about e to the x? E to the x is the inverse of that. Right? So as x goes to infinity, it gets really big really fast. So it's definitely going to go to infinity. But as x goes to negative infinity, what's happening there? It's definitely got a horizontal asymptote at the x-axis. So that limit is 0. We didn't do a limit as x approaches negative infinity for ln x because ln x is not defined there. So it's important to keep that in mind because the domain of ln x is 0 to infinity. So it doesn't make any sense to talk about a limit as x approaches negative infinity. And then just think about what if I switched e to the x to e to the negative x? Now that graph looks like this. So that would swap the limits, right? As x approaches negative infinity, now it's going to go to infinity. As x approaches infinity, now it's going to go to 0. And you don't have to memorize these limits. You just have to be able to figure them out, whether that means that you're aware of the graphs or even just thinking about, again, direct sub sounds kind of funny, but if I plug negative infinity in here, then I have e to the negative negative infinity, which would be like e to the infinity. Well, that's going to be a really big number. Okay. So there's a couple examples here of evaluating some of these infinite limits with these transcendental functions. So let's just go ahead and tackle each one. They're all just a little different. There's not a direct method. You kind of have to just use your knowledge of the functions and your limit laws. So for example, in the first one, we have the limit of a composition. So I can actually take this limit into here first. So I'm going to do arctan of the limit as x approaches to the right of 1 over x minus 2. So as x approaches 2 from the right, 1 over x minus 2 is going to infinity. 2 from the right means that this is going to be just a little bit bigger than 2. So this bottom is going to go to 0, but it'll be slightly positive, and 1 divided by something like that is infinity. So it's like you're saying the arctan of infinity. And we already talked about that as the numbers that you're plugging into arctan get bigger and bigger and bigger. There is a horizontal asymptote of that function at pi over 2. All right. As x approaches 0 from the left, what is happening to e to the 1 over x. So again, let's think about what's happening here. The limit as x approaches 0 from the left of 1 over x. So that's going to go to negative infinity. Okay. You can think of the graph, or you could think of plugging in a very, very, very small negative number here, which is going to give this a very, very, very large number, but it's negative. Okay. And so what happens if this exponent is going to negative infinity? What is e to the negative infinity? What's happening there? That's going to 0. So the limit as x approaches 0 from the left of e to the 1 over x is 0, because it's basically like it's giving you this. And last but not least, we have a rational function this time, and it doesn't involve polynomials, but it does involve e's. And so we're going to use the same technique that we used before for the rational functions, which is we're going to divide everything by the highest power of e to the x, which is just good old e to the x in the denominator. So this technique is useful in this kind of scenario as well, because there's not much more we can do with it. And again, anything with an e to the x left over in the denominator is going to go to 0, because you have a constant over something that's getting really, really big. And so your final answer here will just be -1/2.